In this video, I'll be solving problem 6.1.4 part A. I'll be finding the yield rate for a zero coupon bond when we are given coupon rates and prices for two bonds that do have coupons. So here's the problem statement. We are given the following information about two 10-year bonds. Both bonds have a face amount of 100, coupons payable as usual semi-annually, with next coupon due in a half year. Bond 1, the coupon rate is 4% per year, so that would be 2% per half year, and the coupon amount would be 2, and the price is 85.12. And then bond 2, the coupon rate is 10% per year, so that would be 5% per half year. The price is 133.34. The goal is to find the yield rate for a 10-year zero coupon bond. Okay? So you see this is a Chapter 6 problem from Broverman, and because of that you would know that this must be a problem where you need to think about the term structure of interest rates as being a collection of spot rates on zero coupon bonds, as we talked about recently. But if you didn't know that, how would you guess that you might have to use that idea? Well, the key thing is that we are relating bonds with coupons to zero coupon bonds, and the fact that you are relating those means that we have to then think about the spot rates and the resulting term structure. So let's go ahead and review that idea. So the term structure is a list of things called spot rates. We could call them, say, R1 through R20 here. We've got 20 coupons every half year for 10 years. You also could label them R.5, R1, R1.5, R2, but I'll call them R1, R2, R3. So these subscripts here are going to be in half years instead of full years. You can label it either way, it doesn't really matter as long as you keep the idea consistent in your head. And what do each of these represent then? R sub k in general, where k is 1 through 20. In this context, based on what I just said, would then be an effective semi-annual spot rate for a zero coupon bond, a bond with no coupons. It doesn't give you any coupons, you only get the redemption value at the end. For a zero coupon bond whose term would then be k half years, whose term is k half years. Okay? That's just how I'm choosing to do this labeling. Again, I could have done R sub 0.5, R sub 1, R sub 1.5, etc., and taken the time to be in years, but it seems more natural to me to take these to be effective semi-annual rates that are where the subscript is in the number of half years. Okay? So that's the key thing to think about here once you realize you need to think about the term structure. But I think this problem, as you look at it, still might seem kind of difficult. Like, what in the world are we supposed to do here? I guess the goal would be, based on finding the yield rate for a 10-year zero coupon bond, we'd have to find its effective semi-annual yield rate first, R20. The goal would be to find this and then to convert that to a nominal annual rate, multiply it by 2. And that would be the final answer. Okay? So how do you find that? That's, again, still something that doesn't seem clear. Well, oftentimes when something doesn't seem clear, you might want to just start writing things down and see if by writing those things down it gives you any idea about what to do. And the only thing that seems natural to write down to me here would be the equations of value based on the term structure here. Bond 1, you've got the price being 85.12. That's going to be the present value of all the coupons plus the redemption value. Now you can think of this in terms of the usual idea of an overall yield rate, which in a sense would be maybe an average of these spot rates, but we are thinking about it in terms of these spot rates, this term structure here, so we better get those in there. So you could think of it the long way. You could say, okay, for this bond 1, the effective coupon rate per half year would be 2%, the coupon amount would be 2% of 100, which would be 2. I'd have 2 pulled back in time by 1 half year. Don't multiply it by v like we usually do. Instead, multiply it by 1 plus r1 to the negative 1 power. We got to use the 1 half year spot rate to do that discounting. Okay? And then for the second payment, the second coupon at time 1, don't multiply by v squared. Instead of multiply by 1 plus r2 to the negative 2 power. Use the spot rate for a zero coupon bond over 2 half years, r2, to do your discounting, etc. Guess the last one is going to be plus 2 times 1 plus r20 to the negative 20th power. So those are the discounted values of all the coupons based on this term structure. And then you've got the redemption value, which is 100. You could say plus 100, and that goes back in time 20 periods. It also gets multiplied by this last factor here, 1 plus r20 to the negative 20th power. I'm going to go ahead and write this with summation notation. It's just going to be a little bit more convenient because we're going to have to write this something similar over again. This would be the same as 2 times the sum, k goes from 1 to 20, of 1 plus rk to the negative k power. Okay? We're going to write that summation a few different times here. So that's bond 1. What about bond 2? You can write something similar. 133.34 would have to be the present value of all the coupons and the redemption value based on this term structure. Now again, if you're thinking about realism here, you might be wondering, I mean, do investors really think about term structures like this when they price bonds? No, in reality, bond prices are based on supply and demand. You've got some sellers of bonds, those would be the corporations or the governments, and the buyers, and they're just trying to meet at a price point where they both agree. But you can then think about whether those prices match the term structure or not. Probably in real life they don't quite match exactly, but you would hopefully, it would be a somewhat close match. Anyway, similar idea. It's a 10% coupon rate, so it's 5% per half year, so your coupons are 5 instead of 2. Let me go ahead and write it with summation. You'd have, instead of 2 times this sum, you'd have 5 times this exact same sum. 5 times the sum, k goes from 1 to 20 of 1 plus rk to the negative k power. The last term there from the redemption value is going to be the exact same, plus 100. They both have a face amount of 100, times 1 plus r20 to the negative 20. And I hope at this point you see the benefit of doing this writing down, because your problem-solving skills, mathematically speaking, should be at a point where you'd recognize, hey, if I subtract these two things are going to completely cancel because they're the same, and this and this are going to kind of partially cancel. You're going to end up with a 5 minus 2, a 3 in front of the summation instead of a 2 or 5. So let's go ahead and subtract the top line from the bottom line. I'll just say that verbally, subtract the top from the bottom. So we would do 133.34 minus 85.12. So you get 48.22 on the left side, and then on the right side again, these two things are going to completely cancel. That cancels with that. And these two things, these summations, sort of partially cancel in a sense. You end up with 5 minus 2, or 3 times the summation. And that would allow you to then solve for the summation by dividing both sides by 3. And then that is going to help us solve for R20, because then I can back substitute into either one of these equations in place of the summation, and I'm going to be able to solve for R20 ultimately. Okay, so this is a situation, once again, I emphasize, where it may not be clear what to do at first, but as you think about concepts and just write equations down based on knowledge of those concepts, then maybe the problem solving becomes more clear. So divide this by 3. I get 16.073 repeating. Okay, now take that for the summation, plug it in either equation, the green one or the blue one, for bond 1 or bond 2, it doesn't matter, you should get the same thing either way. Maybe I'll check it both ways. Let's go ahead and plug it into this one first in place of that summation, so I have to multiply it by 2 times 2, and then subtract that from 85.12, so put a negative sign, plus 85.12. That will then equal 100 times 1 plus r20 to the negative 20. I'll go ahead and write that down here. So I'll get 52.973 repeating equals 100 times 1 plus r20 to the negative 20. So divide both sides by 100. Take the reciprocal of both sides, say, and then raise both sides to the 1/20th power, positive 1/20th because I took the reciprocal. So raise it to the 0.05 power, and then subtract 1. R20 looks to be 0.032279, and that is correct. That's not the final answer, though. I'd have to multiply that by 2 to get the nominal annual yield rate on a 10-year zero coupon bond. Multiply that by 2. 0.0646 if you round it. And that is the same as the answer in the answer key. Let's just confirm that if we took the 16.073 repeating and plugged into the bond 2 equation, we get the same answer. 16.07333. Plug it in here, so I got to multiply it by 5. And then subtract that from 133.34. And we do indeed get the 52.973 repeating, just like we did here. We would end up solving for R20 in the same way. And then the final answer is 2 times R20. So about 6.46% for that yield rate on the 10-year zero coupon bond. And again, I re-emphasize that it's when you see that you want to use the relationship between bonds with coupons and zero coupon bonds, that's an idea that you might want to use the term structure idea with the spot rates.